Okay, this video deals with multiplying polynomials by monomials. So it takes it a step further than what we've introduced over the last couple videos. We're now going to be dealing with polynomials, not only monomials. Okay, so in order to do this, we need to introduce a property called distributive property. Now, this might be a reintroduction of the distributive property. We've looked at it in the past, but we'll remind ourselves. Basically, distributive property boils down to this. That's a typo there. Each term in one grouping gets distributed to each term in the next grouping. Okay, so basically what that means for our purposes anyways is you will have a monomial. Okay, so represented here in the general form as A. We're going to multiply that by a binomial, B plus C. It means that this A needs to be distributed to both of the terms. Okay, so that's going to result in A being multiplied by B and A being multiplied by C. Okay, and we recognize that this little plus sign there means that that's going to be a plus sign there as well. Okay, so you could take my word for it that this is a true statement. It is. Mathematicians have proven it. But it's not a bad idea to check it out for ourselves. So I'm not going to do a full proof here, but just to kind of show you how it might work, we're going to use some common numbers that we'll be able to follow along and just check to see if it actually does hold true in this example. So I'm just going to substitute in here, and we're going to multiply 2 times 4 plus 5. Now, we've learned the order of operations that you need to do brackets first, so that means that we would go 2 times 4 plus 5. We'd do that part first because it's in the brackets. 4 plus 5 is 9, so very simply 2 times 9 is equal to 18. Okay, let's see if we apply what we just wrote down in the distributive property to this example, if we end up getting the same result. Okay, so if we have 2 times 4 plus 5, if we're going to distribute that 2 to each of the terms here, okay, we could write out 2 times 4, and we've got an add sign there, so add 2 times 5. Okay, now we can do that math. 2 times 4 is 8, we're adding 2 times 5, so 10, 8 plus 10 is 18, oh good. Okay, it does hold true. You could spend a lot of time doing lots and lots of examples like this, and you'll find that every single time it holds true. Okay, meaning that yes, this distributive property is true, and therefore we can use it in examples like the ones that we'll work through together right now. Okay, so we are going to take 3x and distribute it to 2 plus 3x. Okay, so I like to draw these arrows out. It just keeps me on track what I'm doing. You might choose to do that yourself as well. Okay, so the 3x is distributed to each of these terms. So we've got 3x times 2. So remember from our video a couple times ago, we're going to multiply the coefficients or the number part. So 3 times 2 is 6. Okay, and then we've got an x left over. We look here at that sign, it's a plus, okay? And then we're going to multiply the 3x times 3x. So again, multiply the coefficients first. 3 times 3 is 9. X times x is x squared. Your answer is going to be 6x plus 9x squared. Now, just a side note, it's not a bad idea to start getting in the habit of, usually you'll see in your textbooks, write answers in a specific order that has the term that has the greatest degree written first. So you might see it written like that. Not a bad idea to start writing it in that order. That's kind of the habit that we tend to do. Okay, let's do another example. 4x times 2x minus 1. Again, we're going to distribute this 4x to both terms. So 4x times 2x, coefficients first, so 8. X times x is x squared. Okay, and then we've got a minus sign there, so minus 4x times 1 is 4x. Okay, getting the hang of it. Let's do one more example here. Okay, we've got negative 3x, and we're going to multiply that by 2x plus 5. So again, we're distributing this out to each of the terms, so negative 3x times 2x, is negative 6x squared. Okay, a plus there. Okay, negative 3x times 5 is negative 15x. Okay, now you recognize that we've got a plus a minus, so that's kind of cumbersome, so I'll just we can knock out that plus sign, and basically we have negative 6x squared minus 15x would be our answer there. Okay, so hopefully we're getting the hang of it. We'll see. Here we'll quickly do a word problem as well, just as an example. You might see something like this. We've got dimensions of a rectangle. So right away we see rectangle. Area of a rectangle is equal to reading here. Dimensions of rectangular simple are represented by the expressions 4x and 5x minus 3. So what's the polynomials expression for the area of the gym floor, and write it in simplified form. So area, we just wrote that formula down. We're given what the dimensions are, 4x and 5x minus 3. So all we're going to have to do is multiply those out. So 4x times 5x minus 3, this is just like the ones we've been doing. We use distributive property. Okay. So we have 4x times 5x is 20x squared. 4x times negative 3, right, is going to be negative 12x. Okay, and that is simplified form. That's going to be your answer for the polynomial expression of the area of the gym floor. Okay, hopefully you're getting the hang of that, and that is helpful.